Right. We will last class. Right. So we have seen about the spring constant. We have seen now. For the spring, what we have seen now here, every spring will have a one stiffness constant. That is called a spring constant. Will denote as a K. Length of the spring is L. K into L remains constant. Here, spring constant is inversely proportional to length of the spring. Right. Now, take this one here. What they are saying here, a spring of length L. Spring of length is L and spring constant is K. Is cut into is cut into is cut into two springs of length L1, L2. Now they ask him to find the spring constant of both one. Right. Now see, huh? So here the spring constant, I have a spring we have. The spring constant is K and length is L. Now, when I cut into two parts, the spring constant of that part will changes. It can be any man, maybe 1/3, maybe 2/3, can be anything. So simply they given as L1, L2 they given. So this part, and let us consider this length is L1 and the second part. Now this length is L2. Right. Now we need the how much the spring constant of this part, how much the spring constant of this part we need to get. So how much the spring constant now here for the springs, what you know here, K into L remains constant. Now here, this spring this spring, so we can say what tell me now, K1 into L1. That should be same as K2 into L2. That is same as K into L. For the spring, this will satisfy the relation K into L remains constant. Now I need the K1. So that's why first we'll equate the 1 and 3 terms. So if I equate now, so we'll commit as what element of K1 into L1, which is equal to what element of K into L. From this, we can see now this K1 equal to what, tell me now? This is KL by L1. This is the spring constant of the first spring. Next, similarly, we can say now K2 equal to what, tell me now? This is, we can equate this K2 L2. So we'll equate second and fourth equate now. That is K2 L2, which is equal to what element of K into L. So that's why K2 equal to what, tell me now? KL by L2. These are the spring constant after cutting into two parts. Understood how you need to solve? So here they may say this as that the cutting may be any manner. If they may be equal, may not be equal also. Right? Next. Combination of springs. Combination of springs, the springs we have connected. So the connection can be done as series connection, maybe parallel connection. Now let's see the one by one now. If the springs has been connected in a series connection. So here this is from the rigid support. So from here, have taken one spring, we have taken. This is one spring series connection, and this at the end of the one, another one is connected. Yes, at the end of the one, other fellow started, then that is called, this type of connection is called as series connection. Now we have connected for this whole part, we have connected a block of mass M is connected. So here, this is one spring having spring constant is K1. This is another spring having spring constant is K2. Whenever we do the springs like this type of connection is called as what will be? Series connection. This type of connection is called as a series connection. Means at the end of the one fellow, other fellow joined. That is called as series connection. Now when we connect these two series now here, now whatever the load, how much the load we applied here, this load, how much we have connected here, this is a block is called as a load. How much we have connected this load is now mg. Mg for K1 is mg and K2 is also mg. So that's why in these cases, the restoring force is same. But this spring restoring force means the opposition. So we applied certain amount of force here. So when you connected a spring now here, the spring, what it will do? It will oppose us. It doesn't want to move down. We have spring is this spring, we have connected, some weight is connected. Then what happens now? Because of the weight, the block, the spring will try to elongate. But the spring does not want to be elongate. It wants to be in the same original length only. So for that, there is certain force is developed. Okay, that force which we can call it as a restoring force. Okay, yeah, so we can, yeah, it is like inertia only, not exactly, not exactly. So here the some properties are like that. Okay, now what we can say now here, this spring constant is different, this spring constant is different. Spring constant different means what? Tell me now. Elongation is also different, means stiffness is different. One spring will have a high stiffness, one spring will have low stiffness. Even though same force is applied, what happens now here? High stiffness spring will have a less elongation. Low will have a high elongation we have, isn't it? So that's why the elongation produced in this spring, let us call this as x1. Elongation produced in the spring is x2. So in this case, what happened? You see this thing here. In this case, we say it as what? Tell me now here. Restoring force is same. Series connection. Na? So that's why restoring force is same. Restoring force same. And but elongations are different. Elongations. Elongations different. Okay. Now, the overall equivalent spring constant in this combination. Here we have taken two springs, we have taken equivalent spring constant, which will be given as 1 by K equivalent. That means we have two springs are there. The whole thing we can replace with the one spring only. Okay, how much that spring equivalent we can replace now? That is called as equivalent spring constant. The equivalent spring constant, which is equal to what now? That is 1 by K1 plus 1 by K2. Equivalent spring constant is what? Tell me now. 1 by K equivalent equal to 1 by K1 plus 1 by K2. Here, how many springs we have connected? Two springs. Let us say three springs connected. Then what happens? Plus 1 by K3, 1 by K4, like that it will extend. Okay. So equivalent the, so then what I can do after getting this thing, the two springs we can replace, a single spring we can replace. We can replace it as equivalent of this whole part. We can treat as what tell me now, single spring we can replace as like this. Single spring like this. So this mass, now this is the equivalent spring constant of the two blocks. Okay, this is called it as a equivalent spring constant calculations. How the springs connected here? Parallel, connected, series connection like this. Done. We have series connection, parallel connection. Now here this is identically equal to this thing. This connection is identical to equal to this thing, we can say. Then next. Now let's see the parallel connection. Parallel connection. Parallel connection means starting point, ending point for the two springs are same. Starting point and ending points are same. Then we can call them it as a parallel connection. The two springs connected like that. Now the two springs are started here now at this location. The two springs are ended here. This type of connection will be called as what you tell me now? Parallel connection. This type of connection is called as a parallel connection. Now here the spring constant which is equal to K1, the spring constant is K2. Now in this case, one block only connected for the both. This type of connection is called as a parallel connection. This is the parallel connection. Now the whole thing we can replace as a single spring we can replace now. The whole combination will replace as a single equivalent. Same block we are placing here. Now this is K equivalent we can say now. This is identical equal to this much. Okay. Now in this case, what happens you tell me now? Elongations are same. In this case, which is same? Elongations are same. So, but here restoring forces are different in this case. Restoring forces are different. So in this case, we'll find the equivalent now. So in this case, equivalent spring constant, which will be given as K1 plus K2. Equivalent spring constant simply added. So earlier in series connection, 1 by k equivalent equal to 1 by k1 plus 1 by k2. Right. Here we have taken 2 springs. If you have taken 3 springs, then plus k3, k4 like this will come. We can add them simply. Now let's see this thing here. Let's understand the spring forces here. Now when we have connected a block of mass m is connected. So first you can make the weight now. Tell me now. How much this weight of this block is a mg. Now this is the spring now. So here to understand the spring is nothing but like a string only. Yeah, so here let's understand now. You can treat the spring as a string only. Okay, so then string we have a tension is there now. So tell me now here we have tension. So tension this is upward direction now. So can you tell me how much the tension now? Tension equal to how much now? mg. Tension, there is no acceleration. Okay. So T is equal to how much now? Upward force equal to downward forces. Now the tension is nothing but spring force here. Okay. In the string, we'll call as a tension. In the spring, we are calling it as a spring force. That is only the difference. Okay. Now, so this spring force is also upward direction only. The spring force which will be opposite to elongation. Block will move downward direction now. So that's why a spring force is upward direction. Then how much the spring force now? The spring force which will be equal to mg. Understood this point? That's it. And spring force we know. How much the spring force you tell me now? Spring force formula Fs which is equal to how much now? K into x na. Fs is equal to K into x. So that should be equal to what we can say now? M into G. Where x is a elongation. X is what, tell me now? Elongation. So that means elongation which will be equal to what, tell me now? Mg by K. So that means x is equal to what you tell me now? Mg by K. Where mg is a weight and k is the spring constant. X is what, tell me? Elongation. How much the elongation in the spring is a mg by k. Tension and the spring force both are same only. Tension equal to mg. And the tension is nothing but what, tell me here? Spring force. Yeah, value. They will get the values, they will go how much this value they will mention. That value we can put and we can get an elongation. Now look at here we have two springs has been connected like this. Yeah, so now in these cases, yeah, so then this is what type of connection now here in this case? See one below other na. So two separate blocks. So here, now look at now here. So if we call here this is the first spring. If I call the tension here, that is a T1. And here the tension is how much you tell me now? T2. So tell me how much the tension here? How much? 2 mg. Now here the tension. Yes, how much the tension? 3 mg. 3 mg. Right. That's it. Now we can equate to spring force. Yes, now here this is nothing but what we can say now, spring force in the second spring, Fs2. And this is nothing but what, tell me now, Fs1. So tell me now here, Fs2, which will be equal to 2 mg na? Tension. What is the tension? Tell me now here, we have two blocks, earlier we did same. So we need to see all the blocks below. We need to consider now how many blocks are there. Yeah, spring always massless only. Unless not mentioned, spring string all are massless only. Now 2 mg. So this will be given as what we can say now, K. Spring constant K2 given K only na. So let us say in this now elongation I am calling X2. So this could be given as what we can say now, 2 mg. So from this, how much the elongation in the spring 2 now here? 2 mg by K. This is the elongation in the second spring. Right. Now tell me in the first spring, how much the spring force you tell me in the first spring now? So which will be equal to 3 mg. Now the spring force formula is what, tell me now? K, that is K1 into X1 equal to 3 mg. Here the K1 is given how much? K only. So that means X1 will becomes what, you tell me now? 3 mg by K. So this is the elongation of first spring. Right. Whenever you are finding the elongation, treat the spring as a string only. Find the tension equal to spring force simply. Now tell me this one. Now you tell me now. So understood now, spring force is nothing but tension only. How much the spring force here? Yes, how much the spring force now? How much the spring force here? Yes, so which is equal to 3 mg. Okay. So we are calling this is the first spring, this is the second, this is the third we are calling. Now tell me now here. So then this is how much now here? So this is how much now? 5 mg. And here this is how much? 11 mg. Right. Some, see how much sum. And here you see this thing here. Now here this elongation in this spring, if I call this as x1, this spring is x2, and this is what tell me now, x3. Now you can see now here this one. So this is what we can say now, the spring constant K into x1 equal to how much now? 3 mg na? So how much the x1 now elongation, the first spring is how much? 3 mg by K. Okay. This is the elongation in the first spring. Next, second spring, how much we can say now? Kx2, which will be equal to 5 mg. That means how much is x2 value? Tell me now. 5 mg by k. Here the k values of all the springs given equal. May not be equal also. Next one, third spring. That is k into x3, which is equal to 11 mg. So that means x3 equal to how much now? 11 mg by k. Right. Like this, we need to do spring force first thing. Whenever springs are given, we need to find the spring force. Now, let's see this next. They ask you to find A1. Elongation of the second block, 6 kg block, they ask you to find. Yeah, look at now. Look at now here. So here, first, here, so just imagine now here, this block is, we applied some 100 newtons force is applied. Then obviously this block will try to stop the 4 kg block. But if we apply the more force, then what happens now? There will be some elongation in the spring. Sir, no. And after that, even though after elongation also we apply the more force, then what happens now? First, this 6 kg block try to stop the 4 kg block. If you apply some force now, if your force is more, then it will move. So they already given it is moving to some acceleration given now 15. That means the block is moving. And there will be some, when the spring is get elongated, then we have some force is developed in the spring. Sir, no. Yes, now that force is a spring force now. So here the block is moving this direction, right side, the spring force will be opposed. So that means there is a spring force this direction now, tell me now. Now let's find out the spring force now. And here on this 4 kg block, what are the forces acting? You tell me now. 100 newtons is right side and Fs is left side. Under action of these two forces, the block is moving with the acceleration of 15. Can you write the acceleration equation now? Yes, tell me the acceleration equation now. That is A2 equal to, tell me now here 100 minus Fs by 4. From this we can get the spring force. How much? So this value A2 value given 15 given na 15 into 4 and which will be equal to what, tell me now, 100 minus Fs. Then how much will be the Fs, you tell me now. So that is 100 minus 60. So the spring force is how much, you tell me now. That is 40 newtons. Okay. Right. Now, so because of this 40 newtons of spring force, 6 kg block also will move. Isn't it? Now you tell me now here 4 kg block spring force is this direction. And 6 kg block, the direction of spring force is what, tell me now? This direction. Isn't it? Spring force is always within the spring only. So here at this location, spring is right side part now. Here only the spring force. How much the spring force now here? This is Fs. We got equal and opposite forces. Right. Now you tell me now this 6 kg block, but the forces acting on the 6 kg block, you tell me now. Yes, now 6 kg block, the force acting which is equal to what, tell me now. This is Fs. And what are the other forces acting on the 6 kg block? Mg downward direction. So Mg does not affect this acceleration na. Yes, so that means there is no other force acting na. Now tell me now here acceleration equation we can write. A1 equal to what, tell me now. That is what, tell me now, Fs. There is no other force na. Fs by 6. So we have A1 which is equal to Fs value how much? 40. So 40 by 6 which will be equal to what, tell me now? 20 by 3 meter per second square. Understood? Now, again we start the pulleys. And pulleys will be connected to springs also. Diagram. Yes, small diagrams. So आगे बहुत बढ़िया diagrams आएगा. ముందుంది బోనాలు గుర్తుపెట్టు. ఇంకా పెద్ద diagrams ఉంటాయి. Yes, small diagrams only. Silently do. And what they ask me to find? Hmm. Yes, completed. Listen here. Very simple once you understand. Okay. So next time onwards, we can directly able to write the equations. Listen carefully. So first, so simply as I told you now, we need to do the dot product we need to take. Okay, the dot product between the tension and the acceleration we should take. Dot between the tension and acceleration. If both are same direction, angle is how much? 0. Opposite direction, 180. Cos 180 value, -1. If other than some angle is there, that angle we have to consider. Yeah. Look at now here, each block, we need to apply this dot for each block we need to apply. So you can see now, they already mentioned the directions also. This block is moving which direction? Right side. So here the tension is here now. Okay, now acceleration, tension, same or opposite? Same direction, angle 0. So that means dot product cos 0 value. Yes, 1. So this means we'll come it as what, tell me now? So that is plus A1 into T. Okay, this block over now. Next, coming to next block now here. So this block A2, this is the tension direction now. So positive or negative? Plus what we can say now, A2 into T over A3 we are finding now. So look at now here. So the tension 2T upward directions and A3 downward direction 180 degrees. So that means we'll come it as minus A3 into 2T and finally equated to 0. That's it. No need. This thing. So acceleration ke liye this is only. Then by using this, we can find the relation between the acceleration we can able to find. This is called as a constraint relation. Angle. So this is 2T is which direction? And acceleration is which direction? Angle cos 180 value -1. So T will get cancelled. We'll get A1 value we know now, that is how much now? 4. And A2 value given 6. and which will be equal to, we can say now 2a3, 3 will get cancelled. Now tell me how much is a3 value now, which will be equal to 10 by 2, which is equal to 5. 10 by 2 na. 2 is then a 2t. Right. Then next, you have to be able to apply directly write the equation. Without figure also you can write the equations. But see the figure properly, write the equations. They ask you to find A. For each block you need to apply. Tension given already. A dash. No, for the grading dot only, the method I told you now, same manner. So cos 90, I cos 0 cos, angle you need to see carefully. So tell me the block now, each block, one by one block now, first block. So this is, yes, so this is, now this is 2 now. So we can say this is 2 into t. Right, so this is 2 into t now for this block. Next for this one. So plus only na, plus 2t into a dash. Next for this block, minus 8t equal to 0. So, have you heard the word of constraint equation? Constraint relations. This is called as constraint relations. So find the value of a dash. How much is value? A dash value, which will be equal to 3 meters per second square. Right? Tell me. Next. Here also same thing. Here also same thing. Yes, draw the diagram. So to understand inclined plane na, so you should be able to draw the diagram. Whenever the slant is there, we should be careful. I0. It is moving, yeah. Right. Now look at now here carefully. So see the directions you need to see now here. Tension direction, acceleration direction. Tension is what direction? Tell me now, like this only na? Yes, this direction. And acceleration is also same direction, you tell me now. Angle between these two, how much? So this means what tell me now here? So we can say 2t into a dash. Positive na? Next come into this block. Yes, minus, yes, t into 2 na? Yes, this value 2, which is equal to 0. That's it. T value cancel. So how much is a dash value? Which is equal to 1. Okay. Yeah, this is. But here in the tension calculation, we should do it now. But acceleration, no need to do. Next one. Tell me. Yes. Now tell me now. Right. So this is, yeah, 4 into t minus 2t into a2 equal to 0. So this means what we'll get now? A2 equal to how much? 2 meter per second square. That's it. Next one. Now you have to feel you are learning the concept. First thing, remember. So if you feel that, so drawing that one, it is a difficult, you will never learn the subject. We are learning the complex problems. We are learning for that. You need to feel happy. Answer. Right. So this is 2 into t. Next plus what tell me now? 60. Yes, minus 10t. Yes, plus a dash into t equal to 0 na? So how much is value? 2 plus 6 minus 10 plus a dash equal to 0. So that means how much is a dash value? So that is 2. Now you do it. Not completed. Fast, fast. Write the equation directly. Tell me. Hmm. Tell me the answer. Hmm. Hmm. Yes, so this means what we can say now, 6 into t, okay, minus, for this block, how much the tension? 3t. So this is 3t a dash, which is equal to 0. Okay. So that means how much is a prime value here? That is 2. Ah, 6 by 3. Hello, you might miss the minus sign. Opposite direction, na? Right. Now take it. Tell me this thing. Your wish. In college, they will do only one simple problem they will do. They will say that pull is completed. So because solving this, drawing this thing in the class is very difficult. Hmm. Yes. Now tell me now here tension this direction and the acceleration also this direction only now. Angle between them is 0. So tell me now here 2t into 4. Next this block plus only now. So this is this value. Yes, now yeah, t into 6 now. Yes, now for this block, how much now? Plus only, no? Yes, 3t into A3. A3 now, which is equal to 0. Yeah, tell me now A3 value. So we'll come it as 8 plus 6 plus 3A3. Yeah, which is equal to 0. Then A3 value, how much now? Minus 14 by 3 meter per second square. Yeah, negative. Here it is opposite direction. He given this block moving upward direction, but actually this block will move downward direction. They will move. Right. Next. So that is also pulley. They connected like this. I don't think so. They might be connected some way. So if you want to do this as a connection, the connections it could be like this. You can draw that like this. This is the connection. This is the pulley. They place pulley like that. The pulley they has connected in the air. They connected like this. Here this is the like this. Or you take it as like this. You take this thing fine. Take place like this. Now you will see this. Yeah. See here is a thing. Yeah. Cos 37 4 by 4. Right. Tell me now in this case. We need to take the dot product we should take now. Look at here. Here the thing is tension is like this. This is the string now. So this is a tension. And the block is moving which direction now? The block doesn't move up now. The block move horizontally, they will move like this, they will move. And yes, there is an angle. No need to resolve. This angle is there now. How much this angle? Directly we can take now dot product case. So how much this value tell me now here? This is T into dot product. A bar dot B bar means AB cos theta. A, yes, now this value which is equal to A1 into what, tell me now how much? Cos 37. Understood this step? Yes, now plus here this is T2, this is minus T into A2 equal to, why cos there? Angle 180 na. For that particular block we should see angle. So A1 value given 10, cos 37 value 4 by 5. And which will be equal to A2. So that means how much is A2 value? 8. Thank you.
That what, sir? What about in subtle?
These are two walls. Okay, so a one rod is hanging like that. So here we have one small like a ring shape kind. We have one ring shape is there now. That they connected to pulley via this block. And so here you see this thing, the block will move downward direction and this ring will move right side this direction. Now tell me the accelerations of block A2.
Minus.
Y minus 6. That's right. Yes.
10, 10T, 4 by
So here we have
10T into 4 by 5.
yeah 10 T into cos 37. Okay. Minus T into A2 equal to 0. Yes, so this value here 10 into we have 4 by 5 and which is equal to A2. So that is A2 equal to how much? 8 meter per second. Here the velocities. Now same as acceleration, we should acceleration if I want acceleration dot. Velocity case velocity dot. Okay. Now look at now first. Here mark the tension first of all. Here we have tension T na, and here we have tension T. Right. Now you can see now here. So here this is the tension T is there. Yes. Now here, look at now here. We have the pulleys if we remember. Now here if we have if this is T and this is T, then this is how much you tell me now? 2T. Look at now here, but here this should be horizontal. Now here, this angle given theta, this is T, so will resolve into component now this is, yeah, this value T cos theta. Okay. This is t cos theta. Now you tell me now. This t cos theta. Then how much this value, tell me now? No. T plus, we added these two na. Yes, t plus t cos theta. Understood this point? Tell me. This is the crucial thing here. Yeah. Yeah. Yes. So then this block, let us say this block will move like this. Okay. Now apply same thing. Now this is between these two like acceleration. Now we'll see the dot with the velocities now. Now tell me now t into v naught. Yes. These opposite direction are minus plus this tension t plus t cos theta into this velocity is v na. V that equal to 0. Earlier the acceleration of velocity, that's it. Now t cancel. So this is v naught equal to what we can say now, v into 1 plus cos theta. So that means from this, how much the v value, tell me now? V naught by. Yes, that's the answer. Yosh.